first is by Charles Altshuler, who's the Chief Financial Officer of Globe Metals and Mining.
Thank you so much. I'm here to talk to you about niobium, which we haven't heard about in this conference so far. Niobium is powering the future, facilitating the advancement of next-generation lithium-ion batteries. Our disclaimer is available to be read on our website. So why niobium? Niobium is critically ranked number 3 out of 35 on the US critical metal list. In addition, it's a critical mineral in the EU, in Australia, Japan, and India. It is a metal that has economic importance as well as significant dependency on imports. It's used in industries such as aerospace, the military, and those with the new economy, especially in electronics and renewable energy. This critical label is due to the fact that there's only 3 major producers in the world. 90% of niobium comes from Brazil, and only 1 producer in the world produces niobium oxide. Niobium prices are significantly high for this reason, selling at $58,000 per ton, with increasing prices over the last 4 months. And we can look at the comparison of niobium versus nickel, copper, cobalt, and lithium, significantly higher. Niobium oxide makes batteries greener, cheaper, cleaner, and cobalt-free. Doping niobium into a lithium-ion battery can ensure that the battery can be charged in less than 10 minutes at lower operating temperatures. It increases the energy density of batteries by 200% at a lower material cost and allows 10,000 charge cycles. This is due to the crystalline structure, which facilitates the faster and easier transport of lithium ions into the anode during charging. So assume that a battery without niobium, the atoms move from the cathode to the anode up the street, and there's only 1 parking space. But when you have niobium in it, there are multiple parking spaces to which it can select. And for that reason, it allows for the fast charging of batteries with niobium. Without niobium, the rapid charging can cause lithium-ion metal to accumulate on the graphite surface, leading to performance degradation and risk of fire and short circuit. So how is niobium used today in batteries? Skeleton Technologies in Europe have successfully implemented supercapacitor and super battery energy solutions using niobium. As a case study that they've highlighted, an electric mining truck can, using this technology without fossil fuels, can drive down the ramp between 5 to 15 minutes, depending on the length of the ramp, load for 5 minutes, drive back up the ramp, and unload for 5 minutes while it's on charge for 90 seconds, and then continue the cycle. Major manufacturers like Caterpillar and Komatsu are already progressing with this technology. Niobium in the UK have developed, together with Lotus, the EV, which is a 35 kilowatt-hour battery pack, 200 kilometer range, and recharge in 6 minutes using a 350 kilowatt DC fast charger. So this battery contains a niobium, tungsten, and silicon anode material, and that is opposed to the commonly used graphite. In addition, it's also working on a niobium cathode coating to ensure stability and performance of the cathode material, especially in high nickel compounds. Niobium also specializes in advanced battery materials using niobium, specifically for the robotics and warehouse industry. With the shift towards round-the-clock supply chain, it's imperative that this material handling equipment can be rapidly charged. So Niobium's fast-charging battery answers this pressing need and fostering better productivity and decreased system expenses. And these robots using niobium can be operated in all kinds of warehouses, being ambient, refrigerated, and freezer warehouses, meaning less increase in uptime and fewer robots to complete the job. In terms of power tools, companies like Stanley Black & Decker are now working on rapidly charging batteries in those products at body temperatures, This means that together with battery streak, these lithium-ion batteries can maintain an 80% capacity after 3,000 cycles, compared to conventional batteries, which start to decline after 1,000 cycles. And the reason for this is the nanostructured titanium niobium anode, which has been used in comparison to the normal graphite anode. In 2022, Fortescue acquired the Williams Advanced Engineering. Fortescue's zero-emission targets were at the center of this acquisition. At the same time, CBMM, the world's largest producer of niobium in Brazil, pioneered to create safe batteries in the automotive sector in the Formula E space. The same technology is being used by Williams Advanced Engineering. And Fortescue did not spend $223 million on a racing team to get into racing. This Formula E technology will bring green energy to Fortescue's 3-kilometer-long freight trains and its 400-ton haul trucks, as well as its heavy industrial equipment. VW, Toshiba, and CBMM partnered in Brazil for the development of electric trucks and buses. These have the ability to charge in 10 minutes. Toshiba introduced the niobium titanium oxide in its NTO battery as a next-generation anode material. Ekion in London stands for the foremost provider of niobium-based anode materials for trains. These train operating companies can benefit from fast charging, increasing fleet productivity and route viability. In electric trains, it optimizes the energy density and gives maximum acceleration as well as regenerative braking power. So these batteries in these trains are able to extend the range of electric rolling stock, reduce the need for frequent charging, lowering the track access charges, and fewer overhead line equipment costs. And it's not just batteries. In Japan, the superconducting maglev train uses niobium in its magnet. These trains are capable of reaching 600 kilometers an hour of speeds. And what's more fascinating is that it charges at temperatures, it operates at a temperature of minus 270 degrees centigrade. So by cooling niobium titanium alloy using liquid helium, the system achieves superconductivity. In terms of the aerospace, niobium is used significantly. Its high strength to weight ratio is crucial in the design for reducing the weight of the aircraft while maintaining structural integrity and performance. It's stable at high temperature, which is very important for components that operate at high heat, such as jet engines and rocket propulsion systems. Its enhanced proclivity for weldability and fabricability allows it to produce specific specifications on its very special components. And it's lightweight and durable, which means it can withstand the rigors of takeoff, landing, and of space travel. So what does all this mean for our company, Globe? Globe's JORC resource of 68 million tons allows it to produce 3,000 tons of niobium oxide at full capacity each year. If we look at Fortescue's example in my previous slide, they developed batteries for its 240-ton trucks, showing the feasibility of these projects. Using Fortescue's initiative as a benchmark, it's estimated that the global mining fleet will require between 25,000 to 50,000 megawatt hours of storage capacity. Considering that niobium-based anodes require 5 kilograms of material to store 1 kilowatt hour, with niobium oxide comprising 25 to 50% of the anode material weight, the potential for niobium oxide in mining truck anodes alone is between 30,000 to 100,000 tons of niobium oxide. So to put all that into perspective, Globe's annual production in phase 2 is only 3% of the global mining fleet anode requirements alone. So who is Globe? This bottom quartile cost project has been designed to ensure the production of green niobium such that the Scope 1 and 2 emissions will be the lowest in the world, with hydroelectric and solar power the main sources of power in Malawi. This low carbon footprint is a unique closed cycle which is transformative for the industry. So Globe aims to be the second vertically integrated niobium oxide player in the world. It has a major low-cost resource of niobium in a conflict-free zone in Malawi, Southern Africa, with a strip ratio of less than 1 in phase 1. With an internal rate of return of 47% and NPV of $1 billion US, we have a de-risked phase project startup, 300 tons of niobium oxide in phase 1, with a capex of $30 million, 3,000 tons of niobium oxide in phase 2 on $250 million capex, and a fully auditable origin of materials, which is very important in the battery space. We are fully permitted advanced stage project with all mining licenses and mine development agreements in place, pre-development, shovel-ready, post-BFS, post-feasibility, and a fully compliant JORC resource and reserve. We have achieved milestones in the past 6 months of successfully extracting niobium and tantalum using this environmentally sustainable chlorination refining process. We've confirmed that the niobium and tantalum contains no radioactivity in the refining process. We are currently producing samples for offtake agreements. We have produced a feedstock for our chlorination plant, and we have successfully extracted more than 94% of the key rare earth elements as byproduct of the niobium and tantalum. Both the mine and refinery will be located in Malawi. We've completed our optimization study showing a total unit cost of $18.90 per kg with a selling price in excess of $50 per kg. That's a gross margin of over 70%. Focusing on the future ahead, our milestones are to complete our demonstration plant in May 24 to produce those samples, to produce high purity niobium oxide greater than 99.95% to support the key offtake agreements in Q3 24, to complete an update of the BFS, for the board to approve the financial decision to mine in Q1 25, and then over an 18-month period to build the mine, concentrator, and refinery all in Malawi, and to be in commission and production by 2026. Thank you so much.